The HeteroFoaM Center, based at the University of South Carolina, is creating the discipline of functional materials by design to enable the knowledge-based creation of multiphase, heterogeneous materials used to convert, store, and process energy.
The HeteroFoaM Center is a collaboration of 7 universities and 2 national labs, faculty members and students, to try to create the science of heterofoam materials. The mission of the center really is to create a discipline so that we can make these heterofoam materials by intent and from our knowledge base instead of our experience base. So that's our mission, is to get to the point where we have enough knowledge and understanding to design heterofoam materials.
We have been using computers to design cars, ships, airplanes. And the question is, why can't we use computers to design materials? Well, the reason is that there are many difficult technical challenges involved. And some of them include trying to predict how materials behave from the atomic scale all the way up to the bulk materials themselves. To tackle this, we assembled a team of world-class experts in modeling the behavior of materials across these vast scales, from the electron scale up to the bulk material itself, and also experts that was able to develop imaging techniques down to the nanoscale that can be able to provide 3-dimensional imaging of structures to help the modeling tools complete the theory for the modeling effort. When batteries and fuel cells are made, there's a lot going on, not only at the device level, but all the way down to the electronic level where electricity is generated. By applying these multi-scale modeling concepts, we can understand how a device works all the way down to the constituent materials and how they affect how the electricity is generated. By using these computational tools as design, now we can start understanding how to make materials better, how to make it last longer, how to make the device generate more power, and how to make newer devices, newer batteries and fuel cells.
The key thing is what we try to do with our computations is more than just essentially confirming experiments. We really try to understand mechanisms which are very difficult to experimentally determine. And even more important, we try to rationally design materials so that we essentially can move beyond make and observe methods.
Greater understanding of heterofoams has led to the developments with solid oxide fuel cells, which could have a huge impact on industrial process in the terms of energy efficiency and reduced emissions.
Heterogeneous functional materials are uniquely suited for chemical and energy transformation processes, such as batteries, fuel cells, and supercapacitors. The main reason is that those devices require sophisticated mass and charge transport along surfaces across interface and through porous media. Among all types of fuel cells, solid oxide fuel cells are cleanest, the most efficient chemical to electrical energy conversion systems. It offers the possibility for direct utilization of a wide variety of fuels, from hydrogen to hydrocarbon fuel to coal gas and to gasified solid waste such as biomass. When combined with gas turbine, solid oxide fuel cell has the potential to offer energy efficiency up to 80%. So if we can use solid oxide fuel cell and a turbine to replace the existing coal or gas-fired power plant, the energy efficiency can be doubled while the emission can be dramatically reduced. Rather than completely replace nickel YZ anode, we have modified the surface of nickel YZ using barium oxide to create barium oxide nickel nanostructured interfaces, which demonstrate significantly enhanced tolerance to coking and sulfur poisoning.
Strictly speaking, energy is free. So what do we do with it? It only costs us money when we either store it or convert it to something we want to use it for. So this center is focused on this only real problem we have in energy, and that's how to convert and how to store. So the end result of our center, we hope, is to create a science that allows us to do that based on our knowledge and understanding rather than our experience and trial and error. That's what the center is about. That's the promise of the center.